Hello and welcome. If you are involved in the design, operation, or optimization of process heaters, you know that accuracy is everything. We are the development team at Naftoon Arya, and today we are proud to introduce you to FHinfinity, the next generation of advanced fired heater simulation. We've moved beyond simple calculations. We've built a tool that combines high-fidelity thermodynamics with intuitive 3D visualization, specifically designed for your engineering challenges. Whether you are designing a brand new heater, validating an existing design, optimizing an existing unit, or troubleshooting operational issues, you're in the right place. This tool is built for you. In this presentation, we will walk you through the core capabilities of FHinfinity. We'll show you why a specialized simulator is essential, and we'll directly compare our computational power and features against other major software in the market. So, let's dive in. To give you a clear overview, here's our agenda for today. First, we'll start with a brief introduction to our background and the core philosophy behind FHinfinity. Second, we'll answer a fundamental question: why do we actually need a specialized fired heater simulator? We'll look at the real-world engineering gaps that generic tools often miss. Third, and most importantly, we'll explain why FHinfinity. We'll dive into the technical benchmarks and show you exactly how our capabilities compare to other major software in the market. And finally, we'll wrap up with a short demonstration to see the software in action. Let's get started with the first part. Let's start with a brief introduction to the technical backbone of FHinfinity. Our journey began in 2007 with our first product, evolving into the comprehensive suite you see today. Officially copyrighted since 2018, we are now proud to present the current version, FHinfinity 2025. To ensure a seamless user experience, we've built our interface on the powerful DevExpress framework. This makes the software not just robust, but incredibly user-friendly and intuitive for daily engineering tasks. Visually, we utilize the Dev Department 3D engine for real-time visualization, while our core calculations are driven by optimized C# and VB.NET libraries. But what truly sets us apart is how we've structured our licensing to match your specific needs. We offer 3 distinct tiers. First, the basic plan. This covers all essential design and simulation capabilities for standard fired heaters. Second, the professional plan. This includes everything in basic, plus a suite of advanced diagnostic tools. You get access to the burner simulator, the heat loss analyzer, and perhaps most importantly, Dr. Heater. And finally, the enterprise plan. This is the ultimate package for high-end engineering. It includes all professional features, plus integration with our proprietary Thermo-Engine, NaftPack. NaftPack is 100% extensible and handles complex thermodynamic and even kinetic calculations for your process streams. Now that you know what powers FHinfinity, let's answer the question: why do we need a simulator at all? So, why is a specialized simulator not just a luxury, but a necessity in our industry? We can categorize the needs into 4 key areas. First, design and verification. Whether you are designing a brand new heater from scratch, or you need to verify a design provided by a vendor, you need accuracy. Second, capacity enhancement. Plants change. Needs evolve. Maybe you need to change the burner type to handle a different fuel. Or perhaps you're considering adding 2 rows to the convection section to boost capacity. A simulator lets you model these what-if scenarios instantly, without the risk and cost of physical trial and error. Third, operational troubleshooting. When things go wrong in the field, you need answers fast. Are you seeing high skin temperatures? Is the fuel gas pressure too high? Are you dealing with vibration or positive draft issues? Instead of guessing, a simulator helps you pinpoint the root cause, whether it's a flow imbalance, a burner issue, or a hydraulic bottleneck. And finally, optimization. Every degree of efficiency matters. You have your design efficiency, and then you have your measured efficiency in the plant. Ideally, they should match. But in reality, there is often a gap. If your measured efficiency is lower than design, you are losing money. every single day. A simulator allows us to bridge this gap. It helps us understand why the performance deviates. Is it fouling? Is it excess air? Is it burner imbalance? By comparing measured versus design, we don't just find problems, we find solutions. Now that we've established why we need these capabilities, let's look at which software can actually deliver them. Alright, so we know why we need a simulator. But the next logical question is, why FHinfinity? Generally, there are two main approaches to modeling fired heaters. First, we have coupled modeling, used by respected simulators like Aspen EDR or legacy codes like FRNC 5PC. In our experience, spanning 20 years and over 300 simulations, we've found that while tools like HDRI XFH are powerful, they are often not ideal for specific fired heater engineering tasks. Aspen EDR and FRNC 5PC are suitable, but they are largely limited to conventional cases. Second, we have CFD. Surely, CFD is powerful. But let's be honest, it's often too complex and time-consuming for routine engineering design. And perhaps most critically, it requires extensive validation against pilot plant data or literature to be trusted. So, where does FHinfinity fit in? It sits in the sweet spot. We offer the high-fidelity and engineering-grade accuracy you expect from rigorous models, but with the speed and flexibility you need for real-world projects. Now, it's important to note this. In terms of supported heater types and computational capabilities, FHinfinity goes far beyond both EDR and FRNC 5PC. Think of it this way, whatever they can do, we can do too. But we also offer a vast array of advanced features that they simply don't support. And for those common, conventional cases where both tools are applicable, our benchmark studies show that the results are virtually identical. In the next few slides, we will demonstrate this clearly. We'll present detailed benchmark results against Aspen EDR for standard heaters, proving that we match their accuracy while offering much more. To prove our claims, let's look at a real-world benchmark. We start with case study number 1, the RCS 1T heater. This is a standard cylindrical heater with both radiant and convection sections. It features a vertical, refractory-backed tube layout in the firebox with upfired burners. In the convection section, we have a triangular layout with bare and fin tubes. For this simulation, we modeled a single process stream in a vaporizing state, transitioning from liquid to two-phase flow. We used Aspen HiSys as the thermodynamic engine to ensure consistency across both platforms. Why did we choose this case? Because it represents a conventional design that tools like Aspen EDR handle very well. It's the perfect baseline to show you that where EDR is strong, FHinfinity is equally accurate. Let's look at the numbers. Okay, look at the results. Total heat absorption? The error is near zero. Efficiency? Less than 0.1% difference. Bridge wall temperature? Within 3 degrees. This tells us one thing. FHinfinity is validated. We match the industry standards, but we go further. Averages aren't enough. You need to see the profile. Look at these graphs. Temperature, pressure, velocity, and vapor fraction along the tube length. Across all these charts, the dots show Aspen EDR results and the lines show FHinfinity results. Please note that the red and blue lines refer to the right and left axes of the graph. They overlap almost perfectly. And it's not just about the process side. Look at the tube temperature and gas temperature. Again, the match is exceptional. This means our hydraulic and thermal calculations are not just accurate at the outlet, they are accurate at every single point inside the tube. Now, let's look deeper into the profiles. Accuracy isn't just about the outlet numbers, it's about what happens inside the heater. First, look at the heat fluxes and heat loads. Whether in the radiant section or the convection bank, you can see that the curves for FHinfinity and Aspen EDR are virtually identical. The peak heat flux, the distribution along the tube length, and the accumulated heat load, they all match perfectly. This confirms that our radiation and convection models are capturing the physics exactly as expected. Now, let's talk about the heat transfer coefficients, HTC. For the process side, the blue lines, the match is excellent. But you might notice a deviation in the gas side HTC, the red lines, at the beginning of the convection section. Let me clarify this, because it's an important technical detail. In FHinfinity, we calculate the fin tube HTC based on the total surface area. However, Aspen EDR reports it based on the bare tube area. This is simply a difference in definition. If we convert the bases to be consistent, the red lines would overlap perfectly. So rest assured, the underlying calculation logic is fully aligned. This case study was just one example. In reality, we have benchmarked over 400 different heater models against industry standards. We've published many of these results on our website, FHinfinity.com, and we continue to update this library regularly. We believe in transparency because we know our results speak for themselves. So, to summarize, why FHinfinity? It's not just about matching the competition. It's about exceeding expectations. First, an advanced and intuitive UI. We've made complex engineering simple and user-friendly. Second, extensive heater support. From cylindrical to complex box fireboxes, we cover what others can't. Third, comprehensive features. Both functional and non-functional capabilities that go far beyond standard tools. Fourth, high-fidelity modeling. We simulate real-world phenomena like path imbalance and tramp air with precision. Fifth, powerful diagnostic tools, like our proprietary Dr. Heater for instant analysis and troubleshooting. Sixth, an integrated simulation environment. Heater, burners, fans, transfer line, APH, all in one place. Seventh, structured engineering outputs. Ready-to-use datasheets and reports organized perfectly. Eighth, our proprietary thermokinetic engine, NaftPack. Unmatched flexibility and accuracy. And finally, precise 3D visualization. See your heater, see the temperatures, and understand the physics in real time. In short, FHinfinity gives you the accuracy you trust with the power you need. Now, seeing is believing. Let's move on to a live demonstration of these features in action. Now, let's move from performance numbers to features. We've conducted a comprehensive side-by-side comparison of FHinfinity against Aspen EDR. What you'll see in the next few slides is not just a list of differences, it's a demonstration of flexibility, depth, and engineering power. First, the heater schematic. While EDR provides basic representations, FHinfinity offers a dynamic, interactive schematic that reflects your exact configuration. It's not just a drawing, it's a live map of your simulation, allowing for easier navigation and error checking. Let's talk about firebox types. Aspen EDR supports standard cylindrical and some cubicle designs. But what if you have a box firebox? Or an arbor design? EDR says not supported. FHinfinity supports them all. We cover every major geometry used in refineries and petrochemical plants, ensuring you never have to simplify your model just to fit the software. Now, please pay attention to the concentric circles you see here. And in the following slides. They represent the actual coverage ratio of computational features. The brown circle represents FHinfinity, and the yellow circle represents Aspen EDR. As you can see, the yellow circle is completely inside the brown one. This visually demonstrates that FHinfinity covers 100% of EDR's capabilities, plus a vast array of additional features and calculations that EDR simply does not offer. It's not just an overlap, it's a complete superset. Next, associated equipment. A heater doesn't work in isolation. It has fans, air preheaters, and burners. EDR treats many of these as simple boundary conditions. FHinfinity models them explicitly. We simulate the air preheater, forced and induced draft fans, and even detailed burner characteristics. This allows for a true system-level analysis, not just a tube-side calculation. Firing orientation is critical for heat distribution. EDR supports basic up-fired and down-fired layouts. But modern heaters often use complex sidewall firing, whether perpendicular or parallel, single or multi-level. FHinfinity supports all these configurations. If your burner layout is complex, we can model it accurately. EDR simply cannot. Let's talk about draft calculation. EDR is primarily designed for natural draft. FHinfinity goes further. We support forced draft, induced draft, and balanced draft systems. This means you can simulate heaters with complex fan arrangements and damper controls, exactly as they operate in the field. Even the stack matters. Whether it's self-supported or ground-supported, FHinfinity includes these structural details in its hydraulic calculations. It's these small details that add up to a more accurate pressure drop profile. This is a game changer, the Thermo-Engine. Aspen EDR primarily relies on Aspen properties in an offline mode. It calculates properties once and fills a heat curve table. FHinfinity, however, offers much more flexibility. We integrate with Aspen HiSys, Aspen Properties, and PSIM, supporting both online and offline modes. In the offline method, the simulator calls the Thermo-Engine once to generate the physical properties and populate the heat curve table, similar to EDR. But in the online method, the simulator connects to the Thermo-Engine at every single step of the calculation. It retrieves the exact properties based on the specific enthalpy and pressure at that point. Why does this matter? Because it eliminates interpolation errors. This gives FHinfinity a significant superiority in critical scenarios, such as predicting peak temperatures, where even small interpolation errors can lead to inaccurate results. And furthermore, and perhaps most importantly, FHinfinity has its own proprietary engine, NaftPack. NaftPack allows for reactive systems, custom kinetics, and advanced characterization that generic packages simply cannot handle. It is 100% extensible, meaning it can be customized and extended by the end user to fit specific needs. Modern heaters often use steam or water injection for process requirements. FHinfinity supports steam injection into both the firebox and convection section. We also handle water injection and consider liquid water in tubes. EDR? It lacks these specific capabilities. With FHinfinity, you can model environmental control systems accurately. Engineering is about documentation. When you run a simulation in EDR, you get short version heater datasheet in a simple format. In FHinfinity, you get a complete package. Heater datasheet, burner datasheet, fan datasheets, and APH datasheet. We generate ready-to-use engineering documents for every major component. This saves you hours of manual calculation and formatting. Now, let's look at the technical core, calculation methods. We don't force you into a single black box model. Instead, we give you the freedom to choose the method that best fits your specific fluid and geometry. For example, take bare tube gas side heat transfer. Aspen EDR typically offers just the ESDU method. But in FHinfinity, you have a comprehensive suite, ESDU, Schwepp, Zakauskas, and more. This flexibility isn't just about having options. It's about precision. It gives you the confidence to select the model that aligns perfectly with the true physics of your system, ensuring your results are not just calculated, but validated by the right correlations. You are in control of the accuracy. Continuing with the physics. For process-side pressure drop calculation in two-phase streams, we support mixed model, homogeneous model, Chisholm model, FHinfinity separate model, and user-defined mixed model. Aspen EDR typically offers just the mixed model. For gas emissivity, we go beyond simple gray gas models to include non-gray gas and Lechner methods. This level of detail ensures that even the most complex fluids are modeled correctly. But FHinfinity is more than a simulator. It's a diagnostic suite. We've built specialized tools on top of the core engine. Meet our FH analyzers: combustion analyzer, heat loss analyzer, coke analyzer, and tube life calculator. And our flagship tool, Dr. Heater. These aren't just add-ons. They're specialized engines designed to solve specific operational problems instantly. For deeper troubleshooting, we have FH Extra. Includes the heater troubleshooter and burner troubleshooter, plus an audit data tool to validate your input against real plant data. So, got a problem in the field? Use the heater troubleshooter. Need to audit data? Use the audit data tool. It's like having a senior engineer looking over your shoulder, guiding you to the root cause of any issue. Finally, let's look at special functional options. Need to simulate path flow imbalance? We do it. Tramp air leakage? Included. Damper emulation? Yes. Even transfer line and duct simulation are built in. These features allow you to model the imperfections of real-world operation, not just ideal design conditions. And for the material and environmental side, we handle fuel oil characterization, post-dryout HTC, and even the effect of wind on draft. We also calculate multi-layer refractory heat loss. These non-functional items ensure that your thermal balance is accurate under any condition. So, as you can see, while EDR is a good tool for simple cases, FHinfinity is the comprehensive solution for serious engineering. Now, let's compare FHinfinity with another industry standard, FRNC 5PC. But before we dive into the numbers, it's important to make a fundamental distinction. Technically speaking, FRNC is a legacy program, originally built for mainframe systems. What you see today is essentially a user interface wrapped around an old codebase. This means that despite the GUI, you still often need to manually edit complex input files to access its full capabilities. It's not a fully integrated experience. FHinfinity, on the other hand, is a modern software. It was built from the ground up as a unified, interactive engineering platform. There are no hidden input files, no manual coding, just intuitive, direct interaction. So, in reality, comparing them isn't quite apples to apples. One is a legacy tool, the other is a next-generation solution. However, to be fair and thorough, we will still compare their technical computational results in the following slides. Let's see how a modern software stack performs against a legacy program. First, the user interface. FRNC 5PC uses a legacy, text-heavy interface that can be difficult to navigate and prone to input errors. FHinfinity, built on DevExpress, offers a modern, graphical, and intuitive environment. Real-time validation and clear visual feedback make your workflow faster and less error-prone. Engineering should be about physics, not fighting with the software interface. Next, the heater schematic. In FRNC, the schematic is static and often abstract. In FHinfinity, the schematic is dynamic and interactive. It reflects your actual configuration in real time. You can visualize flow paths, tube layouts, and equipment connections instantly. It's not just a diagram, it's a live model of your heater. Let's talk about outputs. FRNC generates basic text reports that often require significant manual formatting before they can be used in engineering documents. FHinfinity generates professional, structured engineering datasheets and plots. Heater, burner, fan, APH, all formatted and ready for your final report. We save you hours of post-processing time. Now, the core geometry. For standard cylindrical and cubical heaters, both tools perform well. FHinfinity supports all the standard vertical, horizontal, and double-row configurations that FRNC does. So, for conventional designs, you get the same reliability, but with a much better user experience. But here is where the difference becomes stark. Box fireboxes and arbor or U-tube designs. FRNC 5PC has very limited or no native support for these complex geometries. It often forces you to approximate them as cubical, which reduces accuracy. FHinfinity supports them natively. Whether it's a multi-cell box heater or a complex arbor coil, we model it exactly as it is. Look at associated equipment and firing orientation. FRNC lacks native models for forced draft fans, induced draft fans, and detailed burner simulations. It also struggles with complex sidewall firing arrangements, especially parallel multi-level burners. FHinfinity includes all of these. We model the entire system, fans, burners, and complex firing patterns, giving you a complete picture of heater performance. Finally, the engine under the hood, NaftPack versus P-Base. P-Base, the thermo-engine of FRNC, is limited to about 70 pure compounds and basic characterization methods. NaftPack supports over 400 pure compounds. It offers advanced characterization like Lee-Kessler and Rayotze-Daubert. It handles kinetics, user-defined compounds, and is 100% extensible. And unlike P-Base, NaftPack has its own standalone GUI and can integrate online with Aspen HiSys. It's not just an update, it's a generational leap in thermodynamic accuracy. Thank you for your time. For more information, benchmarks, or to request a demo, please visit us at www.fhinfinity.com.